Hey guys, and today we are going to be integraling this using two different ways, which is the trigonometric substitutions, and the another one is just straight up u substitution rule. We will do u substitution rule first. I will set the u as equal to 9 minus x squared. So du is going to be minus 2 times x times dx. Right now we just do some substitutions. U is 9 minus x squared, so the bottom could be switched as square root of just square root of u. I will first divide minus 2 on the du side, so we get this. Now we can just cancel out the remove x times dx from here and replace it with minus 1 over 2 of the integral du. Okay, and now the integral of 1 over square root of u is equal to 1 over square root of u is equal to u to the power of minus 1 over 2. And we integrate this, we add 1 to the power, so we have 1 over 2, and then divide it by whatever the power is. So we get this. But it can be simplified further as 2 times u to the power of 1 over 2. Okay, so we have times 2 times u to the power of 1 over 2, and our value of u is equal to 9 minus x squared, and a plus c, so is equal to minus 9 minus x squared all over by square root plus c. Nice. This is one way that we solved it, and another way is to use the trigonometric substitutions. To do that, I will set the x as is equal to 3 times sine theta. So our value of dx, we differentiated it, we get 3 times cosine theta times d theta. Okay, we do some substitutions. So we have 3 times sine theta times dx, which is 3 times cosine theta times d theta, all over by square root of, that's just 9 minus 9 times sine squared theta. That's x squared, we squared this, so we get 9 times sine squared theta. The bottom, the square root of 9 minus 9 times sine squared theta, we can factor the 9 out to be like this. And then 1 minus sine squared theta from the trigonometry identities, this is cosine 9 times, so cosine squared theta. And square root of 9 times cosine squared theta is equal to 3 times cosine theta. That's very long. So the denominator is now 3 times cosine theta. Okay, and now we can cancel out the 3 times cosine theta and 3 times cosine theta from the top and the bottom. So we have the integral of 3 of integral of sine theta d theta. What's the integral of cosine theta? That is equal to negative cosine theta plus c. But wait a minute. We got the answer differently, and I will explain why these two are equal. Okay, well, this right here, x is equal to 3 sine theta. We can divide 3 on each side, 3 on the both sides. So we have x over 3 is equal to sine theta. And from the triangles, we will call this angle theta. The formula SOHCAHTOA, which basically is, so sine is this O means opposite over the hypotenuse. Opposite is the opposite side from the theta. So this is opposite, and this is adjacent, and this is hypotenuse. So from the SOHCAHTOA, this is sine, we will use this one. So opposite over the hypotenuse. This is opposite over the hypotenuse. So opposite is x and the hypotenuse is 3. So what is this side? From the Pythagorean theorem, this is equal to square root of, 9 minus x squared. Okay, and now we have this. We have cosine theta here. Yeah, we can still do that. So cosine theta, from the SOHCAHTOA rule again, we will use this part. So this shows that it is adjacent over the hypotenuse. So adjacent over the hypotenuse. So this is adjacent over the hypotenuse. So we have 9 minus x squared all over by 3. Now I just simply replace the cosine theta as square root of 9 minus x squared over 3 onto here. So we have minus 3 times square root of 9 minus x squared over 3 plus c. The 3 and the 3 cancel out. So we have minus square root of 9 minus x squared plus c. All right, now they're the same. You see? Okay. Thank you guys so much for watching my video, and see you guys in the next video. Bye.